Hello students, you are most welcome here in my YouTube channel Red Atom Learning Chemistry. Please subscribe my channel if you have not yet subscribed, share it and like it. That will be a great help for me. Today we are going to discuss about aromaticity. You know, this aromaticity is a very important aspect there in general organic chemistry from IIT JEE NEET point of view. This aromaticity is the reason for many properties there shown by organic compounds. See, as I told you, aromaticity that is shown by aromatic hydrocarbons only, and that comes under organic chemistry. That's part of general organic chemistry. See, benzene is the basic, is the primitive, is the first member of the aromatic hydrocarbon. And on what basis you can say that benzene is aromatic in nature? The first condition for the aromaticity shown by benzene is planarity. What is the meaning of planarity? Means the shape of the molecule must be planar. That is, it should show sp2 hybridization. That is called planar. And bond angle will be, 120 degree, as we have discussed this there in our last video. Now, the next important condition for aromaticity is delocalization of the pi electrons. You know, this is pi bond, this is also pi bond, this one is also pi bond. So this pi bond will be delocalized from its position, and after delocalization it will be placed like this there in the benzene ring. This is called delocalization of pi electron. This delocalization of pi electron is also an important condition for the planarity, for the aromaticity of the compound. Now see, the third and the most important thing there for aromaticity shown by any compound is number of pi electrons must be equal to, number of pi electrons must be equal to 4n plus 2. What this is? This is called Hückel's rule. So if any compound is having planarity, if any compound is having alternate single and double bond, that's called conjugation. Alternate single and double bond, that's called conjugation, or you can say delocalization of pi electron. And the compound follows Hückel's rule, that is number of pi electron is equal to 4n plus 2, then that compound will be considered as aromatic. Otherwise, it won't be considered as aromatic. Now see, as I told you, Hückel rule is a very important aspect there in the aromaticity. But in many cases, this Hückel rule is not valid because there will be more than 3 fused aromatic nuclei ring. Now see, 3 fused aromatic nuclei ring means this is one ring, this is second ring, and this one is third ring. This is one ring, this is another ring, this is the third ring. If you'll see in terms of pi bond, instead of this ring, it will be one pi bond, then second pi bond, then third pi bond. So you can say alternate single and double bond. Then next ring will be having 2 pi bonds, and again this last ring will again be having one ring, or you can say 2 pi bonds. So every carbon must be having one single bond and one double bond. That is what the meaning of alternate single and double bond is. See pyrene. Pyrene contains 16 conjugated electrons, that means 8 pi bonds. And coronene contains 24 pi electrons, that means 12 pi bonds. Both are polycyclic. See, this is monocyclic, this one is dicyclic, this one is tricyclic. So if more than one rings are there, that is called polycyclic. So these are polycyclic, are aromatic, but they won't follow 4n plus 2 rule, that is Hückel's rule. But then too, they are aromatic in nature. Now see, Hückel rule is generally applicable theoretically in case of monocyclic systems. This is monocyclic system. So theoretically, in such cases only, this Hückel's rule will be applicable. Now see what aromatic compounds are. There are actually three types of compounds in terms of aromaticity. One is aromatic, second is anti-aromatic, and third is non-aromatic. So this is what we are going to discuss here. As I have already told you, aromatic compounds will always be planar, that is sp2 hybridized, will always be cyclic, that is carbocyclic, and will always be dimagnetic in nature. What is the meaning of dimagnetic? Dimagnetic means can't be magnetized temporarily. They are called dimagnetic. See, as I was talking there in previous slide about the conjugation, what is the meaning of conjugation? Conjugation means alternation. This alternation or conjugation, and that usually alternation or conjugation will be of pi bond in case of aromaticity. That's another very important aspect there for this aromaticity. So usually conjugation having p orbital, and because of this conjugation, they will always be showing electrophilic substitution reaction rather than addition. Why addition? Because double bond is there, unsaturation is there, pi bond is there. Usually compounds which are having pi bond, unsaturated or double bond, they will always be giving addition reactions, but because of this conjugation, here they will be undergoing electrophilic substitution reactions. What does it mean? Means alkene, that is ethene or such compounds, will be showing addition reaction, but benzene will be undergoing electrophilic substitution reaction. As I said that the third condition for the aromaticity of any compound is Hückel's rule, that is number of pi electrons must be equal to 4n plus 2. Now see here, what is the meaning of n? If the number of pi electrons are 6, then n will be equal to 1. See, in this case, here how many pi bonds are there? 3 pi bonds are there. So number of pi electrons will be 6. And now, since number of pi electrons is 6, so n will be equal to 1. So 4 into 1 will be 4. 4 plus 2, 6. 6 is equal to 6. That means it is aromatic in nature. Number of pi electrons must be equal to 4n plus 2. That is called Hückel's rule. If the number of pi electrons are 7 to 12, then in which case it will be 7 to 12? See here, this is naphthalene. This was benzene. Monocyclic it is benzene, and if it is dicyclic, then it is naphthalene. See how easy to remember this. You know, in bio we have studied DNA, RNA. Here, to remember this, you should know BNA. What B is? Benzene, naphthalene, anthracene. Benzene, naphthalene, anthracene. This is monocyclic. This is dicyclic or bicyclic. This is tricyclic. So this is naphthalene. This naphthalene is having how many pi bonds? 1, 2, 3, 4 and 5. Since 5 pi bonds are there, so number of pi electrons will be 10. Number of pi electrons will be 10. And now see, since number of pi electrons are from 7 to 12, so n will be equal to 2. So 4 into 2 plus 2. 4 into 2 will be 8 plus 2, 10. So 10 will be equal to 10. That is, number of pi electrons is equal to 4n plus 2. So it is also aromatic in nature. Now see what next is. If the number of pi electrons are from 13 to 18, then n value will be 3. This is, as I have said, will be anthracene, tricyclic. 1, 2, 3, 4, 5, 6 and 7. 7 pi bonds are there. So 14 pi electrons. 14 pi electrons is equal to 4 into 3. Why 3? Because when the number of pi electrons will be from 13 to 18, n value will be 3. So 4 into 3 plus 2. 4 into 3 is 12 plus 2, 14. So 14 is equal to 14. This is what the meaning of Hückel's rule, and that is for aromatic hydrocarbons only. So this is also aromatic in nature. Now see, if the number of pi electrons are less than 6, then the n value will be 0. If the number of pi electrons are less than 6, then the n value will be 0. So n can be 0, 1, 2, 3, depending upon the number of pi electrons. Now see what next is anti-aromatic. As in case of aromatic, planarity is important. In anti-aromatic also, planarity is important, that is sp2 hybridization. As in aromatic, conjugation was important. Here too in anti-aromatic, conjugation is a must. As there in aromatic, Hückel's rule must be followed. Here too Hückel's rule must be followed. But there Hückel's rule was number of pi electron is equal to 4n plus 2. But here Hückel's rule is number of pi electrons is equal to 4n. Plus 2 is not there. If plus 2 is there, then it will be aromatic. But if it is just simple 4n, then it will be anti-aromatic. So all the three conditions will be same, but there Hückel's rule was 4n plus 2 is equal to number of pi electrons. Here 4n is equal to number of pi electrons. There n value was 1 if the number of pi electrons was 6. But here n value will be 1 if the number of pi electrons is 4. Now see, if the number of pi electrons are 8, then n value will be 2. If the number of pi electrons are 12, n will be 3. And if the number of pi electrons are 16, n value will be 4. See, in this video, we just only be discussing about the aromatic, anti-aromatic and non-aromatic. In next video, we'll be discussing examples, whether that example is aromatic, anti-aromatic or non-aromatic. And then you should know all these properties, then only you can understand that video. Otherwise, it will be difficult for us to know our exact answer without knowing this theory. Now see, last is non-aromatic. If any of these three conditions, what these three conditions are? Planarity. What second is? Conjugation. Conjugation means alternate pi bond. Alternation is very important. And third is Hückel's rule. If any of these three is not followed, if any of these three is not followed, if one is followed and third, if two is followed, two are followed and third is not followed, means any one condition out of these three is not followed, then also it won't be aromatic, it won't be anti-aromatic, it can only be non-aromatic. Now see, so you should know the shape of the molecule also. So see this cyclo octa tetraene. This is planar. because carbon is sp2 hybridized. Double bond, single bond, double bond, single bond, double single means conjugation is also there. But the shape of this molecule is actually, it seems it is planar, but is not planar. It is bucket shaped. It is bucket shaped. Its shape will be like this. In exam, they will give you this structure, but this does not exist. It exists there in this bucket structure. So here, this bucket can't be planar. So this condition won't be followed, but rest two are followed. Then too, it won't be neither aromatic nor anti-aromatic. It will be non-aromatic only. So this is what the meaning of three conditions is. Now see, aromaticity, as I have said, it is because of the delocalization of pi bonds there in planar ring system, that is sp2 closed ring system. And what is the evidence of this aromaticity? Their heats of hydrogenation and heats of combustion will be very low. In case of such compounds which are showing aromaticity, their heats of hydrogenation and their heats of combustion are low. And because of this aromaticity, they will be usually stable. That is their unusual property. What stability is expected? More than that, stability will be there in such compounds because of this aromaticity. And reason is what? Because of this delocalization of electrons, because of this delocalization of pi electrons, they will be attaining extra stability below and above the plane of the molecule. Thank you very much for watching my video. Hope you enjoyed and understood the topic. And just please subscribe my channel, like and share with your friends and family. Thank you very much.